Okay. Right, now. Right. Here we go. Part 2, right? So let me give you a problem. Okay? Let me give you a problem. Are you ready? All right. 100 grams of hydrogen gas. I want you to tell me how many liters that is. I want you to tell me how many moles that is. And I want you to tell me how many particles that is at STP. So 100 grams of H2. I want to know volume, moles, M for moles, or actually that's not true. N is the abbreviation of moles as a variable, right?
Yeah.
This is liters, this is MOL, and this is, we'll call it P, because we can do that. We can make rules up as we want. That person from Kazakhstan is going, no, not that! Okay, so that's important, right? So this is going to be, I don't know, whatever. Neat. What is it?
PAR.
PAO. Oh, I like that. Very good. Okay, now. So, let's change. What do you got to change this to first? What do you have to change that to first? According to this.
Moles.
You have to change it to moles, right?
Yeah.
Correct?
Yeah.
All right, so how many moles is that? Well, let's see. Let's set up a ratio, okay? What's the ratio? 1 mole. Remember, it's defined by the particle. What's the particle? The particle is H2. What's the mass of one particle of H2? Guys?
1.
They told me 1, okay? They told me 1, okay? You're counting or giving me the correct answer? I mean, look, guys, isn't it H2?
2.
One of the biggest mistakes people make in mole relationships and stoichiometry is that they don't read the particle correctly. When I say hydrogen, I mean hydrogen gas. Hydrogen gas. So you would say hydrogen. So I would have said to you, hydrogen gas. Okay? Hydrogen atoms, what would the mass of 1 mole of hydrogen atoms be? 1 gram. What's the mass of 1 mole of hydrogen gas? 2, because you know the gas exists diatomically. So this is going to be 1 mole is per 2 grams equals X moles for 100 grams. So how many moles do I have? 50 moles. So I have 50 moles, correct?
Yep.
Now, you could go either way. Remember, this is mole. I'll make this with just, I'll make it look nice. I'll make it with just, you know, you can put it on your paper, you get a test, and you just put this down right away. You don't have to think about it, okay? I don't do a lot of mnemonics when I teach. But this is one where it's kind of useful. So N is in the center. Do it like trigonal planar. So you have what? Mass, volume, particles. Okay? Yes? 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 Okay. So how many particles is it going to be? I want you to just do this with a calculator. Don't write it on the board. I just want to do it with a calculator. I have 50 moles of hydrogen gas. I'm going to ask you 2 questions. How many moles, how many particles of hydrogen gas are there? Anybody got a number for me? Okay. What does that say? I can't read for that far.
8.312.
Just give it to me without scientific notation. No, you're going to have to give it to me in, sorry, 50 times.
3 times 10 to the 25th.
So it'll be 50 times what? 6.02 times 10 to the 23rd. Shall I write it on the board anyway? So 50 times 6.02 times 10 to the 23rd is going to be what? Genevieve?
3.01 times 10 to the 25th.
3.01 times 10 to the 25th. And how do you get that? Let's erase this one when we found moles and put the other constant ratio. 1 mole, 6.02 times 10 to the 23rd equals what? 50 moles over X. 50 times that divided by 1 is 3.01 times 10 to the 25th. Now, let me ask you a quick question. This will really confuse you. Okay, Ellen, you look like you're in a trance. Is Raina hypnotizing you? Okay, I thought so. Okay, now, how many particles of hydrogen atoms are there?
How many particles are
No. The original question was, how many particles of hydrogen gas are there? And that's actually correct, because each particle of hydrogen gas is H2. But what's the total number of hydrogen atoms involved in this problem?
6.02.
This is for H2, and just H would be what? 2 times that, right?
6.02 times 10 to the
6.0 times, is it 3.01? 3.1?
3.01.
3.01. 3.0 is fine. 3.0 is fine. We're rounded. I mean, 3.0, 3.1, when you're talking about 25 decimal places, we don't really care. No, it's okay. It's okay. Yeah, it's fine. Fine. And that's going to be times 10 to the 25th. So it's going to be twice that, right? Yes? Okay? Do you understand that 3.0 times 10 to the 25th and 3.01 times 10 to the 25th, when you're talking about that many particles, doesn't matter really. Okay, 3.0 or 6.0, right? So don't fall into the trap that a lot of my chemistry students have done in the past, and chemistry students around the world. You just got to understand the process. The end point is, okay, well, we're not actually going to count out that many, so 3.01, 3.0. Okay. So now, what is the volume going to be? What's the volume going to be at STP? Yes.
1,120 liters.
1,000.
120 liters.
20 bananas, what'd you say?
Liters.
Liters? French. Liters. I know, I'm making fun of Jenny. She's great to make fun of. Okay, now, how'd you get that, by the way? Let's put that other ratio. I love constant ratios. They're wonderful. Love them. You know what kind of math you need to do this kind of chemistry? 7th grade math. It's wonderful. Isn't that great? Okay. So let's erase all of this. Let's go crazy and just erase it all. I'm going to live on the edge and erase it all. And what's the ratio, the constant ratio? At STP.
22.4 liters per mole.
Now, does it matter if I say 1 mole over 22.4 liters? Does it matter? No, it does? Maybe. Okay. Well, in other words, this is going to be X, and this is going to be 50 moles, right? But if I said instead 1 mole over 22.4 liters, right? That's going to be 50 moles over X. So the answer is, does it make any difference? The answer is, no, not really. Same thing. I love proportional relationships. When I was a kid, it was the first, what I still consider to be, for an elementary school, middle school student, when I was a kid, it was the first truly, I consider now as an adult, the first truly high-level math that I really understood really well. Proportional relationships. If you simplify a portional relationship, what does it look like? Doesn't it look like algebra? 1x equals,
22.4.
and then solve for x, right? Okay. So so algebra. What's one of the underpinnings really of algebra? It's going to be what? What's an underpinning of algebra? They're really tired. Yes. Proportional relationships, right? Okay. So we're done. Okay. Did I do it right? Yeah. Am I okay? So that's really it. There's nothing more to it than that. Now you just got to do. I think I gave you 6,582,501 problems to do for homework, right? Yeah, easy?
No.
We're off.
Nah.